Okay, good day, everyone. Now, today we are going to look at the waveform of a boost regulator. So let's just have few explanations that will help you. Okay. Now, so from what we did previously, we have a boost regulator, right? And we said at time of on, you have this equivalent circuit, and then at time of off, you have that, okay? You can catch up this in our previous video. Now, we want to now look at the waveforms, okay? So now the first thing is, let's sketch a line, and then here we have the, our switch T on. The time is on, and then here the time is off. So let's just see what happens. All right, this is our switching signal 1 and 0. Okay, now I want to see how will the waveform, the voltage waveform will look like, the voltage across the inductor, right? How will the voltage here look like? That's the first thing. So we check what will happen here. We check what will happen here, the current flowing through there, the current through here, the current here, and the voltage there. All right, so that's what we're going to look at now. All right, the waveforms. Okay, so let's start with the inductor, the voltage across the inductor. Now we said at time of on, the voltage across the inductor is the same thing as Vs. So if I have this as 0 point, so the voltage will be like that, Vs, okay? Okay. And then at time of off, all right, we have that the voltage across the inductor will be Vs minus VL. I mean Vs minus VO. So the voltage across here will be Vs minus VO. All right, this is our voltage there. So you have this like that. Okay, now the next thing again, look at the voltage across here. What about the current flowing through there? Now, remember that this I in, let's say we have zero value here. I in is an average value. Let's say we have I in average. I'm plotting now I against time, right? So I have average value, all right, which is your I in, this I in. But now we see that once you switch this on, the current builds up. Once you switch this off, the current discharges. All right, current, the current is discharged to the load. So now at time of on, so this builds up. All right, at time of off here, at time of off, that current that is built up discharges, all right, to the load, so it discharges. So that you have here to that, this and this. So the distance between this point and that point is your delta I, the ripple, the peak to peak ripple current, delta I. So that if you know the amount of current flowing in, all right, once you know the voltage and you know the current flowing in, then if you are asked to calculate the peak value here, you can easily calculate the peak value by taking this. If I have here, I peak there will now be I in that you have, which is your average input voltage, plus, now, this is your average input voltage, right? So I'm going to add from here to here. Where from here to here is a ripple, this peak to peak, or this ripple divided by 2. That is delta I over 2. All right, the same thing with I minimum will be I in minus delta I over 2, like that. Okay, did you get that? All right, so that is the current flowing through there. Now, remember, the current flowing through here at time of on is the same thing here as time of on. So that means whatever that you have here at time of on is the same thing for the transistor. All right, at time of on. So that if I have a zero value, I mean the reference there, now I'm going to duplicate just this only. All right, so I have like that. At time of on, you have current flowing, but at time of off, there's no current flowing through the transistor. So that you have this. So that means this peak value here is the same thing as a peak value there. Okay? All right, so that means I have this I of the transistor peak is the same thing that you have here. I in plus delta I over 2, the same thing. All right, you get it? Now, when you come to the diode, remember that this is not at zero crossing. Look at the way it starts here. But this is our reference, so this one is not a reference, okay? So this is just the average value. This I average. I in average. So that means our reference is somewhere there. All right, so now the same thing happens to the diode. See, the diode, when this is on, there's no current flows to the diode. No current will not flow to the diode, but once it's off, current flows through diode. So if I want to get I of the diode, right, at time of on, nothing flows through the diode, so I'm going to get nothing. But at time of off, now the current that is flowing through the inductor flows through there, and which is this one. All right. So and this one, you see how it looks like from I in is like that. Okay. So that means you have this. Okay. So that is the current flows through that inductor. The peak value is the same thing as the peak value of the current flowing through the transistor. The same thing. Okay? So I peak here is the same thing as I in plus delta I over 2. The same thing. All right? Did you get that? Okay. All right. So the next thing that we are going to look at is the current flowing through here. All right? Let's see now. Let's look at IC. IC, I hope you are seeing it clearly. IC at time of on. What happens to the current here? When you switch this one on, all right, the current there, okay, will feed the load, IO. Okay, so that means IC will be equal to minus IO. So now the current flowing through here is going to change direction and will be feeding the load. All right, so now that means IC, let's say IC will be minus, if it is zero line, this will be minus, okay, minus IO. That is at time of on. Okay, minus IO at time of on. Now, so at time of off, immediately you switch off this, current is coming from here in there, and this one is feeding, this is feeding the load, right? And the part of it will be feeding this, the capacitor. Capacitor has to be charged, all right? So in other words, I'm going to have the current flowing on the capacitor will be the same thing as how much current is going in here minus IO. All right? So, but we know that this current is going up, down, up, down. So when you have this, so I'm going to get this minus IO. And at this point, this side, we now have, whatever I have here will be with minus IO. Because as this is charging this, okay, this will be discharging also to the load. So if I know the average value on the load, okay, I can subtract that from the current coming in. All right, using Kirchhoff's law. This goes in here, this goes in there, that goes in there. Did you get that? So that means now, so at this point, at the time of off, all right, so I'm going to have the peak value that you have here minus how much that is getting out of that, and it will be discharging this. And this will be discharging also at the same time. So in other words, the current will start reducing the current here, because as the current fills in here, it's charging back there. So it will start reducing, okay, to a certain amount. Did you get that? All right. So you have to a certain amount, and it will come back again to the same minus like that. Okay. So that this point that you have here will be the same thing as IL maximum. This peak value, let me just put peak, this peak value, all right, minus IO, all right, will be the peak of this. And also, even here, will be IL minimum minus IO, all right. So that becomes the waveform for the current flowing through the capacitor. Okay, what happens to the load, the voltage? Okay, so see whether we can see here, right? Let's just check the voltage. Let's check what happens to the voltage. Okay, VO. Now remember that this voltage, as time of on, once you plug this, what happens to the output voltage? Okay, so the output voltage is going to have also a ripple, because this voltage here is a voltage across there. So we are looking at how this is going to be discharged. Once this is on, whatever that is here will be discharged. So the voltage will begin to reduce. Okay, so the voltage drops. Okay, so we are going to have a drop. So you have dropping of the voltage. Immediately you turn this on, then the current goes there again, and the voltage builds up. All right, like that. So in other words, this will be going, discharging, charging, discharging, charging, discharging, charging, just like that. So you are going to have ripple there also at the voltage. Okay, so that you have this as delta V. So you have delta V also. If you got delta V, that means you are going to have the average voltage. All right. So you have our average voltage that goes across the center of that. So this is V average. That is your output voltage, right? The average voltage. So you are going to have ripple voltage also. It will go like that. So you have the peak-to-peak output voltage. Okay. So did you get that? So that is our VO against time. Okay. And this is our IC against time. This is our ID against time. This is our, what did we get here? We have our I in first here against time. Our IP, I of the transistor against time. We have our voltage VL against time. This is IL also, okay, against time. All right, and this is our timing, time of on, time of off, and this is KT. All right. Okay, did you get that? All right. Okay, so thank you very much.